Good afternoon, everyone. This is Diane Fodell. Thank you for joining the Cognitive Systems Institute speaker series today. I'm happy to introduce Alexander Braun, who's the founder of digital strategy boutique consultancy called Creative Construction Heroes. It's in Berlin, Germany, and they have a wide range of clients across all industries. Online from the very first days of the web in 1995, Alex has been active in developing internet projects and startups. From 2003 to 2007, he developed internet-based business models for the media industry in management positions at Bertelsmann in London, Shanghai, and Toronto. Alexander is the author and co-author of books on chatbots and the digital transformation of companies and business models. He holds a Master's of Business and Economics from the University of St. Gallen and completed executive education programs at INSEAD and MIT. Today he's going to talk about one of my favorite subjects, from Eliza to Siri and beyond, the promise and challenges of intelligent language controlled assistants. Thank you, Alex, and I'll turn the call over to you.
Great, thank you. Thanks for the introduction, Diane. Warm welcome to everybody here from Berlin. Thanks for your time. Over the course of the next 20 minutes, I'm going to give you a brief overview about the current state of chatbots, the promises that they hold and the challenges that they face, and what the company's goals are that are engaged in operating in this area. So let's jump right into it. Apple kind of had a head start in 2011 when they launched Siri. After this, there was quite a long time until the next company followed suit, November 2014, with Amazon launching Echo, in contrast to Apple and Siri on the iPhone. That's the device, the speaker in the homes, that is a natural language interface. Afterwards, one big tech company after the other launched Facebook M in October 2015. Then Microsoft Cortana in December 2015. Google Assistant May 2016, and last but definitely not least, also IBM, of course, Watson Conversation as a natural language interface. So with all these big tech players on board, and with them focusing a lot of investments in this area, it became quite obvious that something big seemed to be happening in this space. And of course, it received also expected media coverage, as we see here. Forget apps, now the bots take over. So basically, natural language interfaces are supposed to substitute apps and become the new way of interacting with computers. Why chatbots are replacing apps. So lots of these articles predicting $200 billion chatbot disruptions, the next $1 trillion company that will be based on AI agents, natural language-based chatbots. So it went basically quite a media hype in this whole space. And over the course of the last few months, it has cooled down significantly. Suddenly, the headlines are quite different. Are we still talking about the chatbot revolution? We see here, why does Siri seem so dumb? Facebook spammy chatbots must improve and fast. Please, Facebook, don't make me speak to your awful chatbots, and so on. Tougher Turing tests exposes chatbot stupidity. Is the whole chatbot trend one big misunderstanding? And even David Marcus, the head of Facebook Messenger, said that the whole chatbots were really and are still really overhyped. And let's be honest, chatbots kind of suck. So over the course of the last few months, there's quite a big change in chatbots will rule the world to they're not useful at all. So where are we really in this space? What's really going on there? Are we still in this stage of Clippy? You probably all know and remember Clippy, the natural language operated assistant that used to live within Microsoft Office. Everybody hated it from the get-go. Even the first focus group test that they did with it, people hated it and didn't like it. But it was introduced anyway. I mean, even Bill Gates seems to be a little bit annoyed by Clippy here. And that kind of was the thing that most of the people felt. Clippy was this kind of assistant that always seemed to get in your way. You wanted to get a job done, and there was Clippy, and you had to close Clippy first in order to really be able to get some work done. So with these assistants, are we in the space of Clippy still, or are we moving towards some real AI as we seen it in her? Not sure if all of you have seen this movie. If you haven't, I highly recommend you to watch it. In this movie, Samantha is this chatbot AI system that Theodore falls in love with, and so it's a really, really good movie. I highly recommend you to watch it. When Siri was asked about what she thinks about Samantha, she wasn't that happy about it. Her portrayal of intelligent agent is beyond artificial. No, in my opinion, she gives artificial intelligence a bad name. So if you ask a lot of people that are kind of frustrated with Siri, really, that's probably what they would say about Siri. So what are some of the challenges that we are facing here in this space? Now my presentation was stuck. Here we go. It helps probably to take a look into how we got here. Chatbots are not really a new phenomenon. This is a book I wrote on chatbots in 2003, so 13 years back already. And this by no means was something new back then. The first chatbot was developed by Joseph Weizenbaum of MIT, who developed it in 1966, Eliza, which was a natural language system that kind of played or staged psychotherapist. So by simply paraphrasing or answering, putting questions back to the person talking to the system, it mimicked the psychotherapist without really having any intelligence or complex logic in the system. What Weizenbaum really wanted to prove with the system is that humans are irreplaceable and that humans will be very annoyed quite quickly when communicating with a computer system in natural language. The result, however, was quite to the contrary. A lot of people spent hours and hours talking to Eliza and telling Eliza a lot of very private details that they weren't even sharing with their friends. So this moved Weizenbaum to become really a fierce critic of computer systems and artificial intelligence, because he feared that humans might lose what is special about human beings, and computers might threaten that. We have some of these fears also today with the advancement of AI, with one part of the audience saying basically it's the biggest threat for mankind, and the others saying it's the best thing that ever happened. What happened after Eliza was many years later, was a switch from these crude DOS prompt or command prompt systems into the next step of graphical user interfaces. So idea was here to improve the usability of systems, to make it easier for people to interact with computer systems. And the logical next step in this evolution is using natural language, because humans it's the most natural thing for them to communicate with language. So the whole idea is to make systems even more usable than they currently are with graphical user interfaces. One other motivation behind that, and that is also why especially Microsoft and Facebook are driving this this shift to natural language systems and message-based systems is to create a third runtime after the web and after smartphone apps to get a hold of the market. They basically don't own the mobile operating systems, Android and iOS. So in order to be able to assert more control over what they can do on these devices, their goal is to establish messaging as a third runtime to beat Google and Apple here in this space. So these are several motivations for driving the systems forward. One is the usability and also assertion of power in this market. Now, what are the challenges that we're facing today? Why was there this sudden switch from overhype to now really kind of frustration with chatbots? It helps to first look into the different bot types that we currently have. Most of the chatbots that we are talking about today are rules-based bots. So Siri, Cortana, Viv. Viv is the company founded by the guys who developed Siri. Was just recently sold to Samsung. These bots depend on a huge database with finite information that is coded and created by humans. So basically, any information that's in there is kind of a sophisticated IVR system, so to speak. Information that's not in there, the bot can't answer. So these are the limitations of these rules-based bots, because first of all, people don't really know what the scope of information or the scope of knowledge of the system is when they communicate with it. So they have to find out if the system is able to answer the questions or not. And other than with graphical user phases, where you sort of have an overview what's there and what you can do, is really opaque with these systems because you don't really know what you can do. The other one is created bots. They're kind of a merger between these rules-based bots and human intervention. So basically, they also rely on a huge database of kind of pre-coded information. But if the bot can't answer a certain question, it passes a message on to customer service agent to answer this question. So sort of a combination of rules-based system with a ticketing system, so to speak. So both of these systems aren't really solving or have a lot of shortcomings still. One, the rules-based system, as I said, can be understood if it's not very good as a sort of IVR. The created bot's more like a ticketing system, because if the message is passed on to the human operator, it's then not really real time anymore, and it's also not kind of the most natural interaction that we expect from natural language interfaces. Some of the results we see here, the problems we see can be due to design flaws. This is a bot within the Facebook Messenger, and we see here somebody wanted to unsubscribe from CNN newsfeed, and the bot apparently didn't understand that. Although "can I unsubscribe" doesn't seem to be such a long tail request, the frustration was quite high that this was not possible. Another design flaw here is actually executing the identified command. So here, also within the messenger, somebody unsubscribed and the bot confirmed this, but then kept on sending additional news, which also is not what the user really wanted. And another one that we see here is due to the design of the personality of this chatbot, because sometimes they can get a little bit overboard, the developers, designing these personalities. This bot was supposed to give the user weather and weather forecasts for their location and so on, but it became very playful, and it was hard to decipher what actually the weather now actually is, because the personality was taking up all the message. So that all these things are quite frustrating for the user, and make them quickly switch off these kind of bots. One other problem, and this is due to these rules-based systems, is the maintenance and the up-to-dateness, so to speak, of the database. This is a request that was put not too long ago to Siri, who is a Democratic candidate for president, and Siri didn't find an answer and basically just returned a web search. Also, this question doesn't seem to be such a long tail question that a normal human user would expect it not to answer it. So it's hard for the user then to grasp what kind of a scope of coverage this Siri system has, and it can quickly lead to a lot of frustration on the user side. This is one question I asked it yesterday in German. I apologize for that, because my settings are this way, and I wanted to try out if the same problems exist here, and that's proven. I was asking who on the left-hand side, wer kandidiert für die US-Präsidentschaft, so who's the candidate for the presidency in the US, and this couldn't even answer that, and returned a web search that was also totally out of date. Ted Cruz is running as a candidate, or John McAfee is a candidate. So totally out of place. Every simple web search would have returned a better result than that. So that's also quite frustrating on the user's end. Now, a more complex problem also is common sense. So I'm going to quickly run through this. Some examples here. User, Siri, call me an ambulance, and then Siri answers, okay, from now on, I call you an ambulance. So these are some of the examples. I have some more here, but in respect to the time left, I just leave you with this example, but there are a few things that are quite complex for computers to understand that are very simple for humans to decipher. Quickly flip through those. There are a couple of projects that try to address that, creating common sense databases, OpenPsych, Microsoft, and so on. Now, the vision of the chatbots is really to reduce the friction on the user's end. But what we're seeing here, voice tends to look like the unlimited general purpose UI, but actually it only works if you narrow the domain. So it has the opposite impact. It actually often increases friction because the user doesn't know how narrow the domain is or how wide the domain is, and in turn it becomes as opaque as a common DOS prompt, basically. So these are some learnings that we can draw from that, especially with regards to Siri. So Siri went live with huge expectations that you can then basically answer anything, unlimited general purpose UI. The reality was, however, that it's limited to a not very clearly defined domain. And the problem, user has to find out with trial and error what the domain is. And the result of that is if the user finds out what the domain is, he stops exploring. So even if Siri is improved, it's hard for the user to find out that it has improved because the user learned what the scope of the domain is and doesn't try new things because there's no visual representation of certain changes. So then you're basically stuck with a Siri that basically sends you messages to your contacts, or maybe you can ask it for the weather, but beyond that you don't really explore it anymore. Amazon approached it a little bit different with Alexa. They from the get-go set quite a narrow scope of domains. It was less opaque for the users this way, and therefore less disappointment. But there comes a problem of efficiency and effectiveness. So if I use Alexa to order products from Amazon, I can tell it to order a sponge, but then I have to open my Alexa app on my iPhone or on my smartphone, go to the shopping list, select sponges from there, search Amazon for sponges, wait for iOS open to open the Amazon app, scroll down, and then check out. So a lot of steps that are involved after that don't really make it efficient to order this way. So and if it's not more efficient than the graphical user interface system that is that I could also use, then people are not going to really use it. Here are some examples of how much tabs are involved. So if I use a text-based system here on the left-hand side to order pizza, it takes me 73 tabs to actually place my order. So the alternative on the right-hand side with a classical app, there are only 16 tabs involved. So from the efficiency point of view, it doesn't really make sense in this context to use the system. Also, if there are things to discover, it's much easier to discover new things, different pizza versions and so on, if I have a graphical representation of those. So where do bots work? As a conclusion, there are some usage scenarios where bots are good to use, like if it makes sense to have a lot of information in one thread. So if I book a flight, all the information is in one thread, and I don't need to go through a lot of emails and pull all this information together. I can use the same thread to reply to customer service, to change my flight, and so on. So that's one usage scenario where it makes sense. Another one is if I use this sort of horizontal AI system, but via APIs access a lot of different other systems that execute orders that I place through this text-based system. So a combination basically of language operated and efficient graphical system that we are seeing here. But these are early iterations of this, so we need to find out more really which are the best contexts to make it work. Some of the things that you should think about when evaluating whether a bot is a good system to use in a specific context is if interactions are quick. So the fewer the number of back and forth required, the better, because if you have to type back and forth, it becomes quickly very inefficient, and often graphical representation is much easier. Simple interactions, so not too many options to choose from. So if I'm buying shoes, for instance, I have hundreds of shoes to select from. If I would need to do this in some sort of a chat-based session, it becomes very inefficient. Context is also quite important. So if you can pull in as much information as possible from the get-go, so I don't have to key it in, then it makes a lot of sense. Here's a taxi service, for instance, here in Germany that uses the WhatsApp messaging system, and it automatically pulls in my location because my device knows that, and so I don't need to key in where I am in order to direct a taxi my way. So the more I can infer about the context, the better, and the quicker the interaction. Also very, very important that the users maintain control. So clear permissions, not as we saw in this example before when the user wanted to unsubscribe and the system didn't really respond. And last but not least, users don't have investment in existing apps. So if I already use apps for a specific use case and I spend a lot of time personalizing this app already, then it will be very hard to switch the user to a different voice control system now, or messaging system. So a good use case is usually something that is new or only involves temporary interactions. That's as a quick tour de force through chatbots. I hope there were some interesting insights for you, and thank you very much. So now I'm open for questions.
Thank you, Alex. That was great. That was fun. Audience, please press *1 to unmute your line to ask questions.
Hey, Alex, Jim Sporer here. Thanks for another great presentation. I appreciated your presentation you made in Orlando, Florida earlier this year as well. So good to reconnect.
Thanks. Thanks, Jim.
So here's the question. It's a kind of a tough one, and I wish I could read your chatbot book, but my German's not so good. But do you think that common sense reasoning is going to be a required prerequisite to really get good conversational systems? And my second question is, perception, like speech recognition, image recognition, has really benefited from, deep learning, machine learning with large, big data sets. Do you think it would ever be possible to create a large enough data set to get good conversational systems or good common sense reasoning systems?
Yeah, that really is a tough question. I think, like, for example, this OpenPsych database has been filled with all these common sense reasoning for over the last 30 years. So that's a very tough one to crack, I think. And will these systems be useful even without common sense? I think to a certain degree, yes. I think a lot of things you can do already today with some of these systems provide value already. But if you really want to get to this level that you feel that you're communicating with another human being, so to speak, and not always have to think about what the other understands exactly, I think common sense often becomes a limiter of the conversation then if that's not understood by the system. So I think to answer your question, I think yes, there are quite a number of use cases where these bots can provide value even without common sense. But for the full scope of the communication, there are many use cases where it gets problematic without it. And sorry, your second question about image recognition, and
Yeah, do you think it's possible to get enough, a big enough data set to solve the common sense and conversation problem, or is that just the wrong way to go about it? Because big data sets help with speech recognition and image recognition, but so far haven't been fully successfully applied in the common sense reasoning and conversation area. Do you think big data sets is the way to go, though, ultimately?
I'm not 100% sure, to be honest. I mean, like I said, this OpenPsych, they have been adding data sets over the course of the last 30 years. I'm not sure if that has really improved the whole understanding of common sense and language yet. So I'm not sure if we will have the same results here that we saw with images and image recognition.
Thank you, Alex.
Yeah, thanks.
Other questions for Alex?
Alex, just in the remaining minute or so, this is Scott McLeod. Thanks for a great presentation. What's your understanding of the interlingual chatbot space, the translation chatbot space? What are some of the interesting limitations thus far that might inform subsequent developments, whether it be big data sets or other approaches with AI, for example?
Hi, Scott. Thanks for your question. So the question is, how can these bots be used to communicate between different languages, so to speak, or
Yeah.
I'm not really. I just trying to think of bots that actually do this in different languages. I'm not quite sure. On the top of my head, I can't really think of an example that does this between different languages. Aside of the fact just the language translation, but not so much the actual understanding or translation on a chat-based level? I'm not quite sure. Sorry.
Great. I thank you very much for your fascinating presentations. Really timely.
Thank you.
Thank you. Thanks for the questions, and thanks, Alex. We're out of time, but I just want to thank you for the great presentation. Thanks for being our presenter today, and audience, thanks for attending. We'll see you next week. Thanks again, Alex.
Thank you.